Hi folks, in this video I want to talk about how we can graph an interesting looking plane in that this one is missing a variable, it's missing z. But to do that, let's just compare it to what we know about two-dimensional graphs where we're missing maybe an x or a y. So the example that I have here in 2D is x equals -2. Now we know from previous courses that this is just a vertical line through x equals -2. And what's nice about this is because y is not in the equation, when I plug in -2, 4, it works because the only requirement is that x equals -2. And we don't care what y is. All we care about is that x equals -2 again. So this point's also on there, -2, 1. This point is also down there, -2, -3, and so on. Okay, I could also make a table here to show why why there is no y-intercept. I make a little table, x, y. When I plug in 0 for y, well, that's okay because I just need x to equal -2, and that works out. But if I plug in 0 for x, then my resulting equation says 0 equals -2, which is not true. There is no y value here to solve that problem. If we were looking at something like this, where x plus y equals 13, if I plugged in 0 for x, then I have y equals 13, and I haven't, y can make this equation true. But since there is no y in this equation, that just simply won't work. And so this tells us that there is no solution, no y value that's going to work. And this together tells us that there is no y-intercept. Now, let's take a look at our three-dimensional example now. So I could do the same thing, x, y, z, and we'll see all the parallels from 2 dimensions. First off, since z doesn't show up here, we don't care what z is. Don't care what z is. This equation only depends on x and y. And so I could plug in 0 for y and z to still get my x-intercept. That's going to be, let's see, when I plug in 0 for y, I'll get x equals 7. And then again, z being 0 doesn't really matter because it doesn't show up. And we'll get x-intercept of 7. Likewise, if I plug in 0 for x and z, I'll result in y equals 7. So that's there. But if I plug in 0 for x and y, we're going to get, 0 plus 0 equals 7, which is not true. So since there's no solution here, this tells us that there is no z-intercept. Okay, so let's actually graph this now based on what we know. Sorry, I'm going to move this over just a bit. Alrighty, so now that I have this, I can plot my intercepts, and I'm not going to make it too fancy. I'll just do it right here. That'll be 7. 3, let's see, that'll be 7. And I can draw my xy trace, just like I have been doing. There are my intercepts. Here's my xy trace. Now here's the thing. Since there is no z-intercept, there is no xz trace or yz trace to draw, because the graph is not going to hit the z-axis. So what does this mean? Well, if we think back to what it meant over here, the fact that there was no y-intercept means that the line x equals -2 and the y-axis are actually parallel. The graph is parallel to the y-axis, i.e. it doesn't intersect with it. There is no y-intercept. That's exactly going to be the case here. Our plane now, the plane that we're looking at, because we're in 3 dimensions, the plane is parallel to the z-axis. And so the way we could draw this is, this plane is neither tilting away from us or towards us, and so it just simply goes straight up and straight down. Oops, I missed, but you get the idea. And to draw this now imagine that this is a plane covering up that corner of the room, and then this xy trace, which is right here, That's the XY trace. That's again where the plane chops through the floor. And we can take our eraser here and erase what we cannot see, which would be back here. And I will also erase a little bit of the axes to show them poking out from behind. Like that. Like that. And like that. So this plane is parallel to the Z axis. It goes straight up and down, and it's gonna, when you draw it, you're gonna have to draw it again like a sheet of paper, because we can't draw it like a triangle, because a triangle means that it crosses all three axes, which this one does not. Hopefully this helps.